Good morning, scholars. Good morning, wonderful babies. Good morning, wonderful children. I want to believe you're having a blessed day. It's time to start. It's time to start. So we'll be starting almost immediately. Waiting for the link to be shared on our platforms, and then we'll get started. So please let me know once the link has been shared on the platform. Ezekiel, you're welcome. Can you hear me clearly? Let me know if I'm very audible. Oh, the link has been shared. That's perfect. All right. Thank you so much. So we can start now. We can start now. I love that. That was very fast. So you all are welcome to today's class. This is my face. So it's so nice to have you again. Well, bless God. It's been strenuous. Like, it's been so strenuous. I won't lie to you. I don't want to say I'm weak, but I'm strong. Because we had class till like 8 p.m. yesterday, came back, had to teach you people. I had to pray with you people. Then after praying with you, I think we finished prayer around past 11. I had to go and read. I had to go for overnight class. And waking up, I left there around 5 a.m. Just left my hostel around 8. I had to run down home again because I'm thinking that my babies are having exams and their exam is tomorrow. So, but it's fine. I know that this is like the final lap of everything. After this, now, everybody is free to do whatever they want to do and enjoy life. So, don't worry, in all, it's going to be all right and it's going to be okay. So, you're welcome to the live session. You're welcome. So, one of the things that makes um what's it called? One of the things that makes this live session go viral is that you like the video you are watching currently, and please subscribe if you have not subscribed. Please do so now. Do so now because we are starting almost immediately. I'm trying to open my textbook on my system so that it's going to be it's going to be smooth. So then with that you can continue. So please like the video, and if you know one of your enemies, not your friend now, if you know your enemy that ought to be here that is not here, you can quickly share the video with your enemy. We had like 1,000 views yesterday on the prayer, so I believe that we can have up to like 500 science students here today. So let's just get started. My system is not opening. All right. So I want to believe people are doing well and people you are not panicking about exam. There's no exam tension. You are fine and you are good. So what we want to look at today is equilibrium of forces. I will be very, very fast. You know, we're having several classes today. So, and is this still this mommy that will be taking all those classes? So that maybe I will have time to like calm down and rest. So I don't want to overstress myself. And that's why I would also love to like quickly finish. So I want to look at equilibrium of forces, and after equilibrium of forces, I will move to another aspect, which is what's it called? Waves. So let's just get started. So I'll just give you the two cases that we have. Many of you used to have. How many of you used to have problems under this equilibrium of forces aspect? So I know that a lot of you used to have issues with it. So if you're having issues with any part of equilibrium of forces, if you can just concentrate now in like 40-45 minutes, I want to like settle all the problems you used to have in equilibrium of forces, and with that you should be fine and you should be good. So let's get started. So when we say equilibrium of forces is just talking about how you can like balance the force that is acting on a particular body. Let's assume that you're having a body that is resting on the surface I've started though. I was talking before because I was waiting for some people to join. And something about this topic is that once you are not there when they start till they will finish, you'll be lost. I'm coming. Let me check. I hope you people are still with me. Oh. Right. All right. So let's go ahead. Let's assume that we have. Sorry, I'll be checking the back at intervals. I'm the cameraman at the same time. I'm the teacher. So let's assume that we have an object of 5 kg here, and we have this particular force acting on it, and that force is what? 5 Newton. Another force is acting on it from here, and this force is what? 2 Newton. What will happen? We realize that this body, this object, will say that resultant force, there's something called resultant force for those of you that did not know before, is equal to what? Applied force minus what? Opposing force. Abi, I've taught some of the students in STA before this one. So applied force minus opposing force is equal to what? Resultant force. My applied force is the greater one. So what's the greater one? 5 Newton. What's my opposing force? 2 Newton. Then what's the resultant force? 3 Newton. Then that means this object will actually be moving in this direction with just 3 Newton force. And that's what? 5 kg. Then you can ask me to even calculate the acceleration that is making it to move. So I'll say that F is equal to what? MA. What's my F? 3. What's my mass? 5. Then what's my A? What I'm looking for. A will now be equal to what? 3/5. And you can be getting whatever that will give you. So those are the basics that we used to know under our normal force and whatever. So this equilibrium of forces now, I told you that day that we have it divided into parallel. Yes, we have parallel coplanar forces. Parallel coplanar forces. Parallel coplanar forces, and we have what? Non-parallel coplanar forces. Non-parallel coplanar forces. These are the major two parts that you have under this equilibrium of forces. And when you are talking about parallel coplanar forces is just describing a force like this. Please ensure you follow me. Parallel coplanar forces is describing what? A force like this. When you have something like this, this is a plane from the word coplanar. I explained the last time that coplanar means they are acting on the same plane. So this is the plane. You have a force acting here. You have a force acting here. Abi, you have another force acting here. Then maybe you have a pivot here. And they now say, you now say, take this one to this place, take this one to this place, take this one to this place. Then you now say that sum of clockwise movement is equal to sum of anti-clockwise movement. Don't bother yourself. Now I'm just showing you what parallel coplanar forces look like. So non-parallel coplanar forces now, how do they look like? Non-parallel coplanar forces. Non-parallel coplanar forces, this is how they look like. It looks like you have an object like this, and then you have a force here, and a force here. So the three of them, let's call them A, B, C. What? Non-parallel. Because if I draw them out, this is, are they parallel to each other? Of course not. So they are non-parallel coplanar forces. Why do we say they are coplanar? Because they are acting on a single plane. Why do we say that these ones too, they are coplanar? They are acting on a single plane. But they are parallel to each other. They are parallel to one another. So please take note of that. That's the difference between parallel coplanar forces and non-parallel coplanar forces. So now I'll be starting with non-parallel coplanar forces. Ensure that you follow me. Non-parallel, that's the one that is still like easy to quickly understand. So let's start with non-parallel coplanar forces. Non-parallel. So this is where you need to start writing actually. So let's start with non-parallel coplanar forces. All those ones are just like introduction of what I've been saying. So let's start. Non-parallel coplanar forces. Non-parallel. What I'm teaching you now, some people will see it in their exam tomorrow. I'm so sure of that. But it will be so wrong of you to now come back and tell me that Dr. JP, I know it. but I did not get it. In fact, even God will first look at you that you saw it, but you did not get it. Okay? So please, you just have to get it. So now let's assume that we have an object, a body. Let's say this body is Grace. Then Grace is being acted upon by a particular force, F. Grace herself is having her own weight, Abi, and Grace is still having another force, F, that is acting on her. So let me call this one F, let me call this one T, tension. This is the way they used to act. A body, if this is a body, this body now has a particular weight, and everybody knows that weight will always act downward. Please note it. Wherever you hear the word weight, it will always act downward. If you have an inclined plane like this, how will your weight act? It will still act downward. Don't say it will act like this or like this. Do you get? Don't say it will act like this. It's wrong. It will always act downward. And that is because weight is equal to what? Mg. For those that remember, weight is mg. And since weight is mg, we know that gravity is always towards the earth. And that is why weight must always act downward. So please take note of that. Very, very important. So now, if I have a body that is acted upon by three forces, I have F, I have T, and I have W. And they are now asking me that I should solve these three forces. Maybe they gave me value or they gave me one thing or the other to check out. And I'm asked to solve them or resolve them. You will see it. And I'm asked to resolve the three of them in a non-parallel coplanar forces way. So how would I go about it? That's what we want to look at under non-parallel coplanar forces. That's just it. So now let's all assume that this body now is 4 kg. Do you get? I have a force acting here, I have a force acting here, and I have a force acting here. Do you get? If this is like 4 Newton and this is like 3 Newton, and they now tell me that the angle here is 60 degrees, and they now tell me that this one is like 3 Newton. Please follow me. They are telling me that these are questions will come, then they will ask, or better still, not even 3 Newton. They will call this one F. Then they will now ask you to calculate F. This is how question used to come. They will ask me to calculate F. So when they ask me to calculate F, what am I to do? I have 4 Newton acting here. I have 3 Newton acting here. I have F2 acting here. Then they gave me that, what's it called? This body now is having, this force is making an angle of what? 60 degrees to this particular object. So now what you are going to do is that you have to resolve this thing to a triangle. You resolve to a triangle. Resolve to triangle. You have to give it a triangular form so that you'll be able to resolve it. So if I want to resolve this thing to a triangle now, please follow me. I'll be very, very fast. This is not the time to be spelling out things to you people. You people just have to like start grabbing things once we say it. Do you understand? So now, if I will resolve this thing to a triangle, please, you people should follow now. Let me start with this. Are you following this? You know, I can draw this one like this. And the arrow will face down. And I'll say that this place is what? 3 Newton. Are you with me? This part now that is joining to this thing, I can shift it down. Like, instead of it being up. You know, if this thing now is like this, I don't know if you are following me. If I have another line here like this, the two lines will be parallel to each other. And a mathematician will say that since they are parallel to each other, they are equal. So that means I can say that there's 4 Newton here and there's another 4 Newton here if I shift it down. So this one like this now. How is the arrow pointing? The arrow is pointing towards that side. 4 Newton. Are you with me? Now, this one that is like this now, you know, from looking, it's towards this side. I can now shift it inside. Equilibrium of forces is always confusing, I know, but you just have to like put your mind to it. Let me start again. This arrow is pointing downward, and this is it. This one is pointing towards this side, 4 Newton. Then I shifted it towards the base. Instead of it being here, I shifted towards the base of that 3 Newton. Now, since I've shifted it to the base, this last one now can now enter. Like, I'll shift it back inside. And that is what I will have here now. And this is what I'm having here. So this one is F. Do you get? This one is 4 Newton. This one is 3 Newton. Now, the question will now be that where will the angle be? Everybody will agree with me that this angle is standing between, because if I continue this thing like this, it will go straight. Do you get? I can like dot this thing up now and it will go straight. So this angle is between 3 Newton and 4 Newton. This angle 60 degree. That means 4F is not part of it. So this angle is between 3 Newton and 4 Newton. They are not seeing. Yes. You cannot see the board. Is it true that people cannot see the board? People allow me to be. They can see it. They should open their eyes. Yeah. I cannot do more than this, so is it better now? Can I continue now? All right. All right. Hey, you are now calling. I'm calling my sister. It's okay. Everybody wants to pass. The problem that you can have is if your network is bad. So some of you, your network is bad. You're not saying you cannot see the board. God will forgive you. God has forgiven you, yourself. So now, please, do you understand it to this point now? So now, please, let me even first get it. Do you all understand what I've drawn on the board? So that we know if I should proceed or I should continue. Do you just write, I understand? Don't say yes, I don't know what the yes is for. Do you understand what I had explained, actually? Just say, I understand. Let me know I understand. I understand. I understand. I understand. Oh, good. I love this. I love this. I love this. I love this. You understand, right? You understand excellently. So I love the fact that there's nobody that is saying that he or she does not understand. And the person saying I should come again, I'll come again, but not after this question. Good. Perfect. One more person and I'll continue. Is there anyone else? You understand, right? Good. Let's move. So now, I will notice that this angle 60 degree, if I dot this thing up now, this angle will be between this 3 Newton and 4 Newton. So when I draw my triangle, that angle must be here. Then that means angle 60 degree is here. That's the interpretation. I don't even know if you can see my own head. So that's the interpretation. That's 60 degree. Do you get that? So now, since I know that, then what I'm now going to do now is now that I will say that since they ask you to calculate F, you remember your Pythagoras issue now. So what's, you remember SOHCAHTOA? SOHCAHTOA. Everybody remembers. So since you remember SOHCAHTOA now do this for me, everyone. So what are we now going to, you want to get F. So I can use opposite over hypotenuse, or I can use opposite over adjacent. You know, this side will be the adjacent. This side will be the hypotenuse. Don't go and say this is hypotenuse. You know, hypotenuse is the longest side now. So this is the hypotenuse, this is the adjacent, this is the opposite. Please, do we pick that? So now what I'm now going to say is that what? Sine, which one do you want to use? Let's use opposite over hypotenuse. Sine what? Sine 60 is equal to what? Opposite over hypotenuse. And that will be what? F over what? 4. So everybody wants sine 60. Sine 60 should be 0.8. 8666. That's like root 3 over 2. Abi? I don't know. I'm not a calculator. I don't used to use calculator. Sine 60. I don't know. I just know that either cos, but cos 30 is equal to sine 60. Yes. So I know what I'm saying. So sine 60 is 0.86660 is equal to what? F over 4. Then that means F will now be equal to what? 4 times what? 0.86660. So I don't know what that will give you. You can even multiply that. Whatever it gives you is the answer. So what's the answer to 4 times 0.8660? You can give me that in Newton. So that is what we are going to have there. So what is 4 times 0.8660? Anybody? If you have used your calculator, just help me. 4 times 0.8660. I'm not a calculator here at all. And I cannot use my phone. Anybody with an answer? Nobody has multiplied that thing for us. Kai. This is so bad. 3.46. Thank you. So that will give me what? 3.46 Newton. And that is all. Please, do you get this part now? Let me give you one more question. Please, you can just copy whatever that you have to copy on the board. You can quickly copy whatever you have to copy on the board. Shall we? Please, can I rub the board now? I want to know if I can rub the board. I have a question here already that I want to give you. Can I rub the board? Talk now or never. Can I rub the board? All right, thank you. I think I can rub the board now. All right. I just hope you are writing one way or the other. Now, this is the next question. I'm calling this question out now. Look at this. So, this one is saying what? 10 Newton. And here, he's saying T2. Then, here, he's saying T1. But even not just T1. T1 with tension sign. Then the question now says that find T1 and T2. That's what the question says. The question says that find T1 and T2. And they gave us angle. Angle is 30 degrees. Find T1 and T2. Angle is 30 degrees. So this is the question. Let me check if it's clear. So that's the question. I think the question is clear enough. So you have T1, you have T2, then you are looking for T1 and T2. That's what the question is saying. So let's look at how we can solve that very fast. So just like I taught you, you have to convert it to what? A triangle first. You have to convert it to a triangle. So after you convert it to a triangle, then you can easily solve. So now let's quickly look at it. So now I can do it anyhow. So to make it easy, so let me just do it like this first. I can do 1. Do you get this one pointing down to be what? 10 Newton. Then I can shift this one. I can shift it down here. Do you get? Like it will come here. So that will give me this. And that will be what? T1. Then this last part now, you know, this one now is here. Sure you get. You know, I've shifted this one down. So this part now is now here. So I can shift this one inside. So that one will now like complete this place. If you get the explanation. So that one will now be what? T2. That's one resolution. But don't forget, Where is the angle? The angle is between 10 Newton and T2 because this is 10 Newton and this is T2. So the angle is between what? 10 Newton and T2. Do you get the resolution? Then that means my 30 degree is going to be here. I don't know if someone is getting what I'm saying. You have to ensure that your angle is between what they have given to you to use. That's what you have to ensure. So it will be between 10 Newton and T2. And that is what I've drawn. Do you get that? All right, man. Okay, take care. I should go, man. All right, good night, man. So, do you get that? And I can decide to resolve it like this and say that, okay, this one like this, then I will shift this one down. So when I shift it down, it's going to go like this. Don't shift it down and now make it go like this. So, you know, originally it's standing like this. So when you are bringing it down to it must go like that. It must be parallel to what you are bringing before. So it shifts like this. So it's like this. This is T2. This is 10 Newton. And then I will now close it up with this one. And that one is what? T1. Any of the two is correct. Now, my angle is now between 10 Newton and what? And T2. Abi, 10 Newton and T2. So what's my 10 Newton? 10 Newton, T2. Then that means my 30 degree will be here. Do you understand that? Do you get that, please? Did everybody get the resolution I made on both sides? Iliterate boy. Sẹ́yìn lẹ́fẹ́ lọ ṣe àwọn. Ẹ wá kíyàwó àtàwọn ẹbí ẹgbó oúnjẹ bọ̀. Getting lọ nìyẹn. Alright, Ọlọ́run aṣọ yín. Kẹ̀pàtì tó ní wedding ni. Ọjọ́ lè máa resume. Ọlọ́run àsìn. Ó dàbọ̀. So everybody understands, Abi. So without understanding now, all right, man. Without understanding, so we can solve for T1 and we can solve for T2. So everybody solve for T1 and T2, either of the two diagrams. So you know how to get your T1 and you know how to get your T2. So you can use opposite over what? Adjacent to get T1. And you can use adjacent over hypotenuse to get your T2. So what are my answers? Let me have that very fast. I don't want to sleep on that at all. What are my answers? Please, when you are solving things like this, I don't want to be hearing somebody to say, sir. So what's the resolution? I'm waiting for those that are still drawing. I mean, that are still solving. Jesus. What's the resolution, please? T2 cannot be 5. Whoever is getting that 5, T2 can never be 5. Maybe you joined late too. Don't let me stone you. T2 cannot even 5 symbol. Where are you getting the 5? So your T2 and T1, according to what I'm having here, let me check. Cannot even be. It's 5.77. The answer is 5.77 and 11.55. 11.55. So how many of you got that? This thing is not even hard. It's just do what is on the board. Opposite over adjacent over hypotenuse. I should not be doing that for you. If you are still missing questions like this, then probably you are not ready for the exam itself. You are not ready. You are not ready. All right, so can I call the next question now? And we move to the next question. After this everything under non-parallel coplanar forces. And that's how they used to scare you. You know, forces is not hard. It's not hard, though. Non-parallel coplanar. Can I give you one more question on this, please? I want to know if I can. Go ahead. Should you take one more? How many of you got that? I can't solve for you. Solve it by yourself. You can't be solving questions on all these small works. How will I be solving this one for you? Hey, Bami, JAMB it. Hey. I should be solving trigonometry for you. What's that? What is this? This is opposite over adjacent. That is what? Tan. Tan theta is equal to what? Opposite over adjacent. You don't know how to solve this one. We are now. Tan 30 will now be equal to what? T1 over 10. Solve it yourself. What's adding this one? I'm even the one that has time that I'm solving all this thing. What's this one? The second one is what? Adjacent over hypotenuse. That's sine 30. Sine 30 is equal to what? Adjacent over hypotenuse. And that will be equal to what? 10 over T2. Then solve it. Know this value of sine and solve it there. So let us be behaving like children. Because I'm seeing some people telling me I should be solving it. Okay. You can draw the angle anyhow you want to do it. Anyhow you shall did it, you will get 5.77 for this one. You will get 11.55 for this one. We are JAMB. Let's be sharp. You cannot solve tan 30 is equal to T1 over 10. I don't know what I will say about that one then. Please, the next question. The next question, please. The question is like this. Come here. That is 6. So this one is 6 Newton. This one is 6 root 3 Newton. Why this one is what? 12 Newton. Then this one is what? Theta. So the question now says that calculate theta. That's the question. The question says that we should calculate theta. That's what the question is saying. So is there a way your theta is here? I don't know. The board is looking far. But it cannot be closer than that. Calculate theta. So everybody, even before I draw it, can you quickly draw what your resolution will look like from everything we have been saying since morning? Can you quickly show me how your resolution will look like? Let's have it. Let me quickly have your resolution, please. I hope I'm not blocking anybody, Sha. So if I would draw for my resolution, everybody, if I would draw for my resolution, this is what I'm going to do. I'm going to have it like this, just like you have been doing it before. I can bring, do you know that I can bring, you can draw it anyhow. Just ensure that it makes sense. That's why I used to call it cut and carry. When you cut it, you carry it. When you cut it, you carry it. Do you get? So I can decide that I want to first shift this one to this side. Then I'll use this one to cover it. Do you get? Like it will be like this. This one is like this. Then this one will be like this. And I'll now use this one to cover it. Do you get? And I can decide that I want to shift this one to this place. That it will now be like this. Like this. This one will now cover it. But you have to ensure that what you are drawing is very correct. That's the problem. Once what you are drawing is not correct, you are doing nonsense. So you will not do nonsense. So I can decide to shift this one to this place and push this one inside. It will still look like this. It's just for your ability to be able to cut it and carry it. But this one, just think of it whichever way that is best for you. I can shift it to this side, you understand, and push this one inside. Anyhow you want to do it. So let's resolve on one. Let's agree on one. So let me, how best do I put it? Let me bring, you know that this line now, this line is parallel to this line. I hope you know. This line that theta is inside is parallel to this line. So I can say that this line is equal to this line, then shift this one inside. So with that understanding, I can say that this, then this, then this. Then this line, do you get? This line is my 6 root 3. 6 root 3 Newton. Then this line is my 6 Newton. This line is 6 Newton. Then hypotenuse 12 Newton. Abi. Then the angle is between 6 Newton. You know 6 Newton is parallel to this line. So the angle is between 6 Newton and 12 Newton. So that's theta. And they asked me to look for what? To look for theta. So do I need to stress myself on that? No. So I can use either adjacent and opposite, opposite and hypotenuse, opposite or adjacent and hypotenuse, anyone. So let me say that, which one should I use? Let me use sine. No, let me use adjacent over hypotenuse. Let's use that one. So if I want to, what's adjacent and hypotenuse? That's cos. So cos theta is equal to what? Adjacent over what? Hypotenuse. So what's cos theta? We are looking for theta. Cos theta will now be equal to what's adjacent? 6. Abi, what's hypotenuse? 12. That will be equal to what? 0.5. Then I will now say that theta will now be equal to what? Cos minus 1, 0.5. That should be what's arc sine 0.5. That should be like 60 degree. So theta will now be equal to what? 60 degree. That's what is there. It's not hard. Please, do you understand this explanation? I don't want to be talking to myself. Do you people understand this explanation? Come on. All right. Do you all understand? We all understand the explanation, but wow, that's perfect. That's perfect. I love that. I love that. Oh, great. 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 So now, how do you get sine inverse without calculator? Very good question. I was thinking that I would do that. I will make a video for you on that. There's no sign on your calculator. There's no time, and there's no course. There's nothing like that there. So before you go to your exam hall, everybody should listen. I told you in the last video, I said 30, 45, 60, 90, and 120. Know the sign, know the time, and know the course. Do you get? So for your sine 30 is 0.5. Cos 30, cos 60 is 0.5. Sine 60 is 0.8660. Sine 90 is 1, I guess, if I'm not mistaken. Cos 90 is 91. I don't know. Okay, yes, sine 90 is 1. Cos 0, okay, there's cos 0 to cos 0 is 1. So cos 90 is 0. Then you can look for the rest. I don't know them. That's just the problem. The point is that when I was doing JAMB, I crammed it. Sure you get. But I'm not doing JAMB again. Is it that you are still doing JAMB? So it's just needed for you to just learn it. Another thing that you need to cram, let me just say cram, before you go to your exam hall, is log 0 to log 10. Please write it somewhere. Log 0 to log 10. Cram it. And the reason why you need log 0 to log 10 is because you will need it for your pH calculation. And some of you even need it under some calculations in physics that is not even related to pH. But in case they ask you some pH questions, please, they will not be giving you, your pH is minus logarithm to base 10 hydrogen ion concentration. Now imagine that your hydrogen ion concentration is now 3. How will you get it? There's no calculator to solve it. That's why I'm saying that you have to ensure that you go to the exam hall with those values, log 0 to log 10, then sine, tan, and cos of 30, 45, 60, 90, 120. There's one question in remix under projectile, but we did not do it when we were doing projectile, that they asked that at what angle should a particular something shoot, that it will get, they are just saying that at what angle will you shoot that your maximum height will be equal to 3 times your range. So at what angle? And that question, the answer was later 53 degree. And normally, there's no how you want to solve and you'll be getting 53 degree on your normal calculator that you are using in JAMB. So you just have to use scope. So far, you know sine 45. You know everything that is under this 45. So you know that 53 is just a little bit above 45 or a little bit below 60. And it was the only one that was in that range. So it was easy to pick 53. But if you don't know these things, it will be difficult for you. But it won't be difficult for you. So please, just learn it. That's just the truth. Learn sine 30, sine 40, sine gbogbo before you go to your exam hall, because it can be very dangerous if you don't learn it. May you not tell stories that touches the heart. I don't pray that for you. So, should we take one more questions before we leave that aspect? I don't know if we should take one more question before we leave that aspect, or you people are already shining in the Lord. Shall we? I want to know if we should take one more question. You people are already okay. But I'm not getting response. Should we take one more question? Nobody's responding. Okay. All right. So let's take one more question then. I think everybody wants question. Let's take it. I want to stop this one soon so that we can finish latest by 1. Then we'll do waves to 2. There's just one part of waves I want to quickly talk about. Then everybody will go and eat, because I know that some of you now, your stomach is already folding. You don't just know how to say it. And those of you that you are saying it on the discussion group that you have already eaten, is he a sin? Is he a kiniko? You are not serious. You are not serious. Damn this tomorrow. The only thing that is coming to your head now, see, well, it is fine, Sha. Some of us, Sha, is going to be fine. When I'm going for exams, I used to fast. In fact, sometimes I would have been fasting days before, because I know that this exam, God, even the exams that I failed, I am so sure that I fast to the exam. And I've started these things since I was in like GSS2. Sincerely, I'm not trying to hype, since like GSS2, and that's like 2015 or 2016. That's since when I've started that. Whenever I have exam, I have tests, I have anything that is just related to exam, I just ensure that I fast. All through my exam, I will fast. Even that, yes. See, now I cannot even advise you that you should be fasting on your exam day. That's me now. Like, I can't advise that you should fast on your exam day, which is JAMB, because of the tension. You can get to the exam hall and what's it called? There will be delay. Do you get? There will be delay. You might want to write the exam by 12, and you feel like, okay, once I'm done by 2, sure you get, I'll come and eat. But now you get to the exam hall and they are telling you by 12 o'clock that those are out to write by 9. They have not even entered. Do you get? That means it's even possible that hunger can make you eat before you even write the exam. I don't know if somebody's getting what I'm saying, but most times, when I used to write my exam, it's always like 6 a.m. or 9 a.m. I've never eaten jam by 12, by 3. I've never eaten those times before. So, but the point is this: if you fast before the day, we don't need to be fasting on our exam day if we are fasted before the day. That's just the truth. I don't need to be reading on my exam day if I've read before the day. But some of you don't still understand that. It's fine. It's fine, no? You'll be good, eh? You'll be fine. I was not saying you mistakenly ate. Ah! Oluwa Ọlọ́run. You mistakenly ate what? What are you eating? Food that it will still tire you. It only shows that you never put that fasting in mind. That's the interpretation. Because if you put it in mind, when you wake up, the first thing that is coming to me, that I'm not your student, I'm not a student, I'm fasting with you people. Your tutors, they fasted yesterday. You that you are now the, what's it called? The student. I laugh. You that you are not the student, you are not the one that you are eating like food is running away. Okay? I won't say more. Whatever a man sows, he shall reap. Even if not for nothing, God should be like, this girl has fasted. Let me allow her to pass because she has fasted. But now, you are eating. Food all the time. Muslims and Mistors gone, they fasted. They fasted. You that you are not a Christian. Some of you are even in choir in church. I will abuse you. You're not the one doing like a baby. I mistakenly when I first saw that thing, I was like, you mistakenly ate. Do people eat by mistake? Even during Ramadan, if you tell someone that you eat by mistake, is it possible? You only eat by mistake because your mind is not there. If your mind is there, you can never eat by mistake. It's never possible. In the figure above, F1, F2, and F3 acting at a point O, are in equilibrium. Are in equilibrium. If the magnitude of F1 and F2, if the magnitude of F1 and F2 are 100 Newton, and 50 Newton respectively. 100 Newton and 50 Newton respectively. Find the magnitude. Find the magnitude of force F3. That's the question. So I've drawn the diagram. What you have in F1 is 100 Newton. What you have in F2 is 50 Newton. What you have in F3 is question mark because that's what you are looking for. Then the angle is 60 degrees. Then this is the point O where they are meeting. Then the question now, let me read the question to you, everybody. Everybody, let me read the question. Or can you see the board? Can everybody see the board and write it? I think it's actually very clear. So, I think it's clear, Abby. I think it's clear. In the figure above, F1, F2, and F3 acting at a point O are in equilibrium if the magnitude of F1 and F2 are 100 Newton and 50 Newton respectively. Find the magnitude of force F3. So that is what is there. Find the magnitude of force F3. I go again. In the figure above, F1, F2, and F3 acting at a point O are in equilibrium. If the magnitude of F1 and F2 are 100 Newton and 50 Newton respectively. Find the magnitude of force F3. Shano has gotten 86.6. Crystal Bell, mommy. Otsade by 86.6. No time. And that's very correct. I love that. That's very, very correct. That's very, very correct. You need to move to wave. Don't rush. Don't rush. What if they ask you this question tomorrow? Wave might not even come out for you. If they bombard you with 5 of these questions, my dear, you might first be shaking. The one they asked me last year, I could not solve it. I was just looking like monkey. Despite the fact that I know Igluba of us is so well. So let's be guided. All right, now look at this question, everybody. There's no how you want to resolve this thing that to give you something like this. It can never give you right angle. Because if you look at it, there's nothing right and there's nothing left in this thing. Do you get what I'm saying? There's nothing right angle there. Even if this one is acting like this, there's no one that will, do you get? There's no straight one that will come like this. There's no one like this here. And if you check the ones you have been doing before, there's always something like this. But in this one, there's nothing like that. So we have to resolve this into a normal triangle. A normal triangle. And after resolving it to a normal triangle, we'll now be using our cosine rule, our sine rule to solve it. Don't tell me you don't understand though. This is the last one I'm doing on this aspect. So now let's follow. So let me just erase this part and draw it. So now everybody look up. You will agree with me that this line that is here can go out of here like this. Do you get? Let me make this one straight. Let me make this line straight. It's looking off. So what's this? 60 degree. What's there? 50 Newton. F2 equals 50 Newton. So now you will agree with me that this way, that this line is, we can make it continue like this. Now, good. If you agree like that, let me erase this part. All right, F1 equals 100 here. Then that means I can adjust this one to look like this. Do you get? Then I can look at this, so you can see that this one is like this. So I can still make this one too. This one to also be here. I don't know if someone is getting what I'm drawing. I only readjusted this line like this. Then this line is the one that I replicated here. Then this line is the one that I replicated here. So immediately I replicated it, I already have my triangle. But this triangle is not right angled. That's the point. This triangle is not what? Right angled. I don't know if, just try and follow. I know it might be looking so confusing because it's the first time. Now, there's something we call corresponding angle in mathematics, that whenever you have something like this, look up. Whatever angle that is here is the angle that will be here. How many of you went to good secondary schools? They should teach you that. If the angle here is A, the angle here will be A. If the angle here is B, the angle here too is going to be B. Good secondary school. Then that means since the angle here is 60 degree, the angle that will be here too will be 60 degree. My very good students, I hope you are following. Now, if this place is now 60 degree, angle on a straight line is what? 180. Then by the time I do 180 minus 60, then that means what is left here is what? 120 degree. You see that it's not even right angle at all. Are you still with me? So once you know that you are getting there. So this one now, this dotted line is F3. This one on this side is what? Is F1, which is equal to what? 100 Newton. Now, I already have my, I hope nobody is confused so far. Please, I hope nobody's confused to where I am now. I hope nobody's confused. Please, I need to know. I don't want to finish and you tell me you don't understand. I hope no one is confused. Ẹ dákun ẹ sọ̀rọ̀. No confusion. All right. All right. Others ńkọ́? Others ńkọ́? All right. Thank you so much. All right. Thank you. So now, since there's no confusion, then I can now redraw this triangle that I've gotten. That triangle will now look like this. It will look like this. And it will look like this. This triangle. Then this place is what? 120. Then this place, you don't know the angle that is here. I hope you know. There is where students make mistake. Oh, you know it's the total angle that is here that is 60. So don't now say that because you have cut it, this place will be 30. Ta ló sọ fún ẹ bẹ́ẹ̀? Who told you that? You have cut it into two, leave it. You don't know what is there. You only prove all those things by calculation. You can't just say it's 30. It will be so unfair. Then this place is what? F1, which is equal to what? 100 Newton. And then this place is F3 that we are looking for. That's all. And this place, this bottom, is F2, which is what? 50 Newton. And cosine rule states that what? A is equal to what? All right, I'm back. So sorry about that. Can you hear me now? Hey, can you hear me now? You should be able to hear me now. Please, what was the last thing you heard me say? It was my microphone that went off. Okay, I should recap with the explanation. All right, let me recap. I said this. Mike has not died yet. And I was talking about this, that these are the equations or the formulas of cosine rule that we used to use. And I said that my C is on the hypotenuse side. Do you get? So I'll say that my C square is equal to what's my A? 50 square plus 100 square minus 2 into bracket what? 50 times 100 cos 120. Do you get? So now C square will now be equal to what? 2,500 plus what? 1,000. Do you get that? Plus 1,000, I mean, plus 10,000 minus 2 into bracket 5,000 cos 120. Is that clear? So now C square will now be equal to what? 12,500 minus is 5,000. 12,500 minus this will give me 10,000 into bracket abi 10,000 cos 120. You to just try and do what I'm doing. You don't have to be following directly with everything I'm saying. What I did here is I added 2,500 with 10,000. I got 12,005. I multiplied 2,000 with 5, abi 2 with 5,000. I got 10,000. Then cos 120. So I'm not asking that it's cos 120 minus 0.5 or plus 0.5. I'm saying that is cos 120 minus 0.5 or plus 0.5. So that's what I need. Oh my goodness. So the mic has been dead for long. And we'll do another one. Cos 120 is C minus 0.5 or plus 0.5. That's what I just want to know. I'm not a calculator, so that's why I'm having issues. Holy Ghost. So what do we say our answer is? So I'm waiting for those that are still trying to help me get the cos 120. Where are we, please? So cos 120, I've not even checked. Minus 0.5. I should start again. Jesus. All right, let's quickly recap the question, please. Because of I did not know where the mic went off. That's the issue. But everybody edged the question, so I don't want to hear nonsense. So everybody edged the question. I want to start all over again now. I want to start all over again now. If you not like, you should not listen again. I explained how we got to this place. I explained to everybody how I cut out this part. F3 is still F3 here. How this one is still this one. And how this one is this one. I explained. Then I said that to solve it now, we would cut out our triangle, which is this one. When you cut it out, it will look like this. Let me make it bigger. When you cut out your triangle, it will be something like this. Good. And I said, you can't say that this place is 60 degree. You cannot. Because we cut this part now is what? Is we cut it out of 60 degrees. So we can't say what is there is 60 degree. And I said that, I explained how we got 60 here and how we got 120 here too. Everybody still remember that what we are having here now is what? Is 120 degree. Everybody still remembers. I guess, I believe, I agree. Now, since everybody still remember that, then this place now is what? F1, which is 100 Newton. This place is what? F2, which is what? 50 Newton. This place is what? F3, which we are looking for. Then I now mentioned cosine rule that it says that what? A square is equal to what? B square plus C square minus 2BC cos A. Then B square is equal to what? A square plus C square minus 2AC cos B. Then I mentioned C square that is equal to what? A square plus B square minus 2AB cos C. And we are going to be using this last one. Then I now said that C square will now be equal to what? A square plus B square minus 2AB cos C. So this is what we are going to be using. Oh, in fact, I just even remember something now. We will change this sign to positive because we are not using the sign that, we are not using the angle that came directly with it. Yeah, that's, I'm not even sure those people that got 86, maybe they will be correct now. You have to, because if it is the angle that came here, like, you know, I said there's 60 degree here for those that were following. That if this place is 60 degree, this place will be 60 degree. So for those that were following. So if you are using that 60 degree, you know that's the angle that came with it. That's the angle that is between F1 and F3 originally. Everybody should listen now. The angle between F1 and F1 and F2 originally is 60 degree. Do you get? If you are using this 60 degree, it's going to be minus. But if you are now using this one that is inside, you know that's 120, is going to be plus. Yeah, I just remember that now. If you are using the given angle between F1 and F2 originally, you are going to be using minus. If you are using the one that you later got by derivation that is now inside and not where it used to be, you'll be using plus. So use any one. So if I'm using 120 degree, I'm going to use positive sign. If I'm using 60 degree, I'm going to use negative sign. Anyhow it fits for you. So now, let's pick anyone now. Maybe we should use the one of, what's it called? 60. Let's do 60. Let's do 120. So C square will now be equal to what? What's my A? My A is what? 50 plus 100 square minus 2 into bracket what? 50 times 100 cos what? Cos 60, since we are using minus. So C square will now be equal to what? 2,500 plus what? 1,000, I be 10,000 minus 2 into bracket 5,000 cos what? Cos 60. What's cos 60 now? 0.5. Abi. C square will now be equal to what? This one give me what? 12,500 minus 10,000. Abi. Minus 10,000 into bracket what? 0.5. So what would that give me? 0.5 will turn this one to what? To 5,000 if I'm not mistaken. Yes. C square will now be equal to what? 12,500 minus 5,000. Then C square will now be equal to what? 7,500. Then C will now be equal to what? Square root of what? 7,500. What will that now give us? So what will that give us? I don't know. Anybody? Square root of 7,500. What's the square root of 7,500? Anybody? 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 86.6. Where? There is 500. I don't know what they are saying. Yeah, he's saying it's 500. 10,000 times 0.05 is not 500. Please. Yeah, are you people sleeping? This one is 50 times 100. 50 times 100 is 5,000 now. 5,000 times 2 is what? Is it not 10,000? And 10,000 times 0.5 is 5,000 now. Abi, who is not saying? Am I wrong? I'm not wrong now. It's 50 times 100. 50 times 100 is 5,000. Abi, what are people saying? I don't get it too. I'm not wrong now. It's not 500. It can't be 500. More simple calculation money. Okay, you said it looks like 1,000. No, it's not looking like 1,000. It's 10,000. Then you to do the multiplication yourself, you will get it. So we are saying is what? 86.6 Newton. So what will make the difference is that if you are now using 120, you know by the time 120 gets to this place now, you'll be using plus, plus, plus. But because 120 is now minus 0.5, so it will still later return to minus and you still get the same answer. You can try that 120 on out and let's see how it goes. Can I rub the board now, please? Sorry about the mic that went off. Sorry about the mic. So, please, can I rub the board? I want to move to parallel coplanar forces. So, Joe. I'll just solve 2 questions on parallel coplanar forces, and that's all on equilibrium of forces. You can't hear me, K. Has my voice gone dim? Those are the people that they are still where the mic went off. You know, a lot of people are watching the live at different time. So some people now they are still where we started from. So they have not joined us. So they will still say, so I can't hear you. Yeah, I understand. You hear us on. So please, can I proceed now? I think I can rub the board. I guess I can rub the board. I think I can rub the board. I'm waiting for those that are writing. Can I rub it off, Adriel? All right, proceed. Thank you. So try out that 120 and use plus. So anytime you are using the angle that, listen carefully, that they gave you directly in between, you'll be using minus. Do you get? But I'm saying that in this diagram that you have drawn, it's wrong for you to write 60 here. Very, very wrong. Like, very absolutely wrong for you to write 60 here. Because this part, if you will say that this place is 60, 60 plus 120 is already what? Is already 180. Do you get? 180 and angle in a triangle is 180. So what's that here? Is it 0? It can't be 0. And it's wrong for you to put 30 because we have to use calculation to confirm the angle that is here. That's what I'm saying. So whenever you're using the angle that they gave you directly in between them, you use negative. Whenever you're using the one that you got by yourself, you use plus. So I think I can rub the board now. So that's all on non-parallel coplanar forces. Just know that you are using SOHCAHTOA for one and you are using cosine rule for one, depending on the diagram. So they can ask you that what are the conditions? The conditions for parallel coplanar forces. Abi, for non-parallel coplanar forces, what are the conditions? The first condition is that they must act on the same plane. They can ask you this one as like theoretical question. They must act on the same plane. That's the first condition. Number 2, They must be concurrent. They must be concurrent. And being concurrent means that they act at the same time. They must be concurrent, meaning that they act at the same time. They must be concurrent, meaning they act at the same time. So please go and take note of that in case they ask you to think about, to talk about it. Those are the things that they used to use to shock you people, and you'll be feeling like, what are they saying? So they must act at the same time. They must be concurrent. So those are the things that just have to be, just have to know. So, and you still have to know that resolution, Abi, their resolution must be able to be represented by a triangle. They must be representable. They must be represented or representable in a triangle. In a triangle. Do you get? Then the next one, they can the algebraic sum, the algebraic sum, the algebraic sum of the three forces. The algebraic sum of the three forces must be zero. The algebraic form or sum of the three forces must be zero. The algebraic sum of the three forces must be zero. So those are the things that they used to ask you. You can just take note of that. So I think I can rub the board now. I can rub the board. I want to quickly do parallel coplanar forces now. Parallel coplanar forces. So in case you have not picked everything I said, just back the video. Can back the video. Yeah, back the video. Thank you. So let's quickly do what's it called? I'm tired. I'm strengthened. Parallel coplanar forces. I need good sleep. Please, to those of you that you have not filled the form, I advise you to go and fill it too. The form is very important for those that want to associate with Episteme Scholars Academy, but it's not compulsory. It's not compulsory. It's not compulsory. So let's talk about parallel coplanar forces. I'm yawning. So the first thing to note that the parallel coplanar forces, the parallel coplanar forces operate on the principle of moment. The parallel coplanar forces operate on the principle of moment. So please note that the parallel coplanar forces, what's it called? Operate on the principle of moment. Then the next question is, what is moment? Moment is the product of force times what? Perpendicular distance. Perpendicular distance. So it's force times distance, but the distance is perpendicular distance. So you can say that the unit will be what? Newton meter. Abi, force is Newton, distance is meter, Newton meter. But you remember that force times distance is also work. For those of you that you are physics students, force times distance is also work. But we used to say that work is scalar, but moment is vector. And why is moment vector? Because the direction is specified, perpendicular distance. Do you get that? So please take note of that. So the next thing that you need to note under this aspect now is that what are the principles of movement. And the principles of movement is just like two. So let's quickly talk about the principles of movement. So the first principle of movement is that the sum of the upward force must be equal to the sum of the downward force. That's the first principle of movement. Why the second one is saying that sum of clockwise movement must be equal to the what? Sum of anti-clockwise movements. Those are the principles of movement. Number one, sum of the upward force must be equal to what? Sum of the what? Downward force. Then number two, sum of clockwise movement must be equal to what? Sum of anti-clockwise movement. Once you know this, you have known everything. And that's all you need. So let's call questions under that aspect so that we can start waves. Those that have filled the form before should not go and refill the form. You can't even fill it twice because it only accepts one response. Those that have filled it before, leave it. Your name will be reviewed. I'm talking to those that have not filled the form and they know that they want to be associated with the Episteme Scholars Academy. So let me draw the line there. Can we go now? Are you done with us on the board? Sum of the upward forces is equal to the sum of the downward forces. And number two, sum of the clockwise movement is equal to the sum of what? Anti-clockwise movement. Those are the things that you need to note. Sorry. Okay, so yes, sir. Ẹ fẹ́ já ewúro. Ẹ já. Sorry about that. So can we proceed now, everybody? Okay, let's proceed. So now, the way questions used to come is that they will ask you, they will give, okay, let's start. Let's even just start. Let me start. Let me start this way so that it will not look too bulky. So if this is a plane, and it says that this is a 3 Newton force, this is a 7 Newton force, this is a fulcrum, everybody should look up, and they say that this is a 13 Newton force, and they now say that between this place and this place is 2 centimeter. This place and this place 1 centimeter. This place and this place 5 centimeter. They now ask you to calculate the moment of each of the forces. Calculate moment of each of the forces. Calculate moment of each of the forces. So if you see a question like this, how will you go about it? So you start, you say I for what? F1. So let's say F1 is what? Is 13. I know that moment is equal to what? Force times what? Perpendicular distance. So what's the force? 13 Newton. What's the perpendicular distance? That's the distance to the fulcrum. And that's just what? 1 centimeter. But you know that 1 centimeter now, because how best do I put it? Because you have to convert it to meter. So that will be 1 times 0.01. I don't know if someone is getting what I'm saying now. It will be 1 times 0.01 because you are calculating moment. And formula for moment is what? Newton meter. So whatever your answer is, get it there. So number two, for F2, moment is equal to what? Force times what? Perpendicular distance. That will be what? 3 times what? Times 2 centimeter. To convert 2 centimeter, you multiply by 0.01. Whatever the answer is, write it there. Number 3 is now what? For F3, can say that moment is equal to what? Force times what? Perpendicular distance, which will now be equal to what? 7 times what? Times 5 centimeter times 0.01. So what will be your answer in each cases? I want to believe that your calculators are ready. So I'm expecting answers from you all. Please drop for the answers for F1, drop for F2, and drop for F3, and let us move on from there. Everybody, I want to believe you people are still in class, and I'm not the only one talking. On Jesus' name. On Christ the Son, lead rock I stand. My strength is renewed. All of the ground is sinking sound. All of the ground is sinking sound. On Christ the Son, lead rock I stand. All of the ground is sinking sound. All of the ground is sinking sound. Christ alone, who can flesh, fullness of God in a place with the Spirit of God, righteousness. Can I go on? Wow, 1 million videos, 1 million views. That's great. I guess I can continue now, please. The time is enough for everybody to have gotten the answer. So, all right. All right. So, I guess you are good now. We can proceed. 2 times 3. Okay. Am I saying well? For F2, the moment is 2 times 3. For F2. Yes. Thank you. Thank you. No, it's not even 2 times 3. It's 3 times 3. Sorry, that's a mistake. For F2, because we are going to the fulcrum, so that is 2 plus 1. That's one of the mistakes that we used to make. That's 3 times 3. Sorry about that. 3 times 3. So, and that should give you something like 9, 0.09, blah, blah, blah. So that's that. So please, let's correct that. All right. So now let's now move to the soft part. Now, when questions will come, the way questions will come for you is that an object of clinical on a uniform meter rule First listen. You tell you that a uniform meter rule, one object is lying at 20 centimeter mark, the object is 20 kg, the fulcrum is at 40, and then 40, then another mass of 50 kg is at 80 centimeter mark. Then they now place the tension at 30 centimeter mark. Then they will now ask you that you should calculate this, calculate that. That's the student used to have problem, and that's where you'll be using anti-clockwise movement is equal to what? Clockwise movement. So let me just call a question and show you how questions used to come on that aspect. So there's nothing hard there. So everybody, let's take down a question. Let me look for a question. I'm coming. I'm trying to look for a question for you people. Coming. Mm-hmm. All right, let's take this question. A weightless rod. Maybe I should write it so that we can solve together. Uniform rod. Mn of length 50 meter is placed horizontally on a pivot on a pivot placed 10 meter from M. If the weight of 20 Newton and 5 Newton if the weight of 20 Newton and 5 Newton are hung at M and N respectively, determine whether the rod will remain balanced or rotate from the pivot. I'm trying to. Will you people be able to? No. Let's not start with this question. Sorry if you have been writing. The question is not even asking us to calculate it. The question is asking us to determine. Sorry. But it does not matter. Let's finish it. Whether the rod will what? Whether the rod. I'm trying to look for the question. Sorry. Determine whether the rod will remain balanced. Let's continue. Will remain balanced or rotate about the pivot. So let's go. Let's start. A weightless uniform rod. I'm reading the question now. A weightless uniform rod, Mn, of length 50 meter, is placed horizontally on a pivot. placed 10 meters from M. Placed 10 meters from M. Full stop. If the weight of 20 Newton and 5 Newton, if the weight of 20 Newton and 5 Newton are hung at M and N, respectively, determine whether the rod will remain balanced or rotate about the pivot. Determine whether the rod will remain balanced or rotate about the pivot. So let's start. So now let's move. So let's look into this. How can I go about it? So what I want to say here is now that you have your pivot. You have your rod. Your rod is what? MN. Your rod is MN. And since your rod is MN, what's the next thing that you need to do? Since your rod is MN, they now said that a weightless uniform rod MN of length, what? 50 meters. So that means from here to here is what? 50 meters. Is placed horizontally on a pivot. Placed 10 meters from M. So that means the pivot is what? 10 meters away from M. Then that means, let me put this one on top so that it's not confuse us. So they place the pivot 10 meters away from M. Everybody should look up. They place this pivot 10 meters away from M. That's it. 10 meters away from M. If the weight of 20 Newton and 5 Newton are hung at M and N respectively, they now hang a weight of what? 20 Newton at M and a weight of what? 5 Newton at N. That's how to know. They're asking that. So if this place is 10, what would this place be? You already know that it will be 40 because that's the remaining thing in that part. So they're asking that, will the rod still remain balanced like this or it will rotate about the pivot? When you ask questions like this, please ensure that you are not allowing yourself to get so much distracted about what's it called? You are not allowed to, you don't need to allow yourself to be distracted because of the length of whatever they have written. Just be reading it small. Yeah, let's read it together again. A weightless uniform rod, MN. I've drawn the MN. Of length 50 meters. This is the length 50 meters. Is placed horizontally on a pivot. I place it horizontally on a pivot, which is placed 10 meters from M. That pivot is 10 meters away from M. So if it is 10 meters away from M, it will be 40 meters away from N. If the weight of 20 Newton and 5 Newton are hung at M and N respectively. So on M, I hang a weight of what? 20 Newton. And on N, I hang a weight of what? 5 Newton respectively. Determine whether the rod will remain balanced. So they're asking that will this rod remain balanced at this point or it will not. So what am I to calculate? Moment. So I know that moment of force 20 Newton. What would be the moment of 40 Newton? That would be what? Force times what? Distance. What's the force? 20. What's the distance? 10. Abi, that would give me what? 200 Newton. Then moment of the 5 Newton. That would give me what? 5 times 40. So what would that give me? That would give me what? 200 Newton. So I got 200 on both sides. The question is, will this thing rotate about the pivot? No, it will not rotate about the pivot. The reason why it will not rotate about the pivot is that the moment on both sides are equal. So you can say that since moment of M is equal to moment of N, there will be no rotation. There is no rotation. That's all you need to know. There will be no rotation. So because they are not what? They are having equal whatever that I can think of. Oh yeah, let's take a question on the tough one. The tough one. Ah. Ah. Ooh. Jabo. Mm. Mm. So can I call the question now? I'm waiting for those that are probably writing. Can I rub the board, please? All right, so let me rub the board. Hey. So the question says that I'm trying to look for good. These questions are looking too tough to start with. That's why I don't want to call them yet. Good. Everybody, let's look at this now. So on 5 centimeter mark, you have a weight of 200 Newton. Then 15 on 5 centimeter mark. Then on 15, you have the fulcrum. Then on 45, you have another weight of 40 Newton. This is 45 and this is 50. So this is what we have and this is 0. So the question is stating and is wanting us to calculate weight of the rod. Weight of the rod. So the question wants us to calculate the weight of the rod. So now let me quickly take note of some things. Let me quickly make you to note some things. Note. If your question states that a light uniform meter rule, note this for your calculation. If your question says that a light uniform meter rule, then that means that meter rule lacks weight. That's why they said it is light. And at the same time, it is 100 centimeter or 1 meter. If your question says that a light uniform meter rule, the interpretation is that it lacks weight and it is 100 centimeter and 1 meter. But that does not mean that always, whenever you hear the word a light meter rule, you should be thinking that it is uniform. Not all meter rule are uniform. What makes a meter rule uniform is that it has 100 centimeter, 1 meter gradation. What makes a uniform meter rule light is that it lacks weight. So I can have a uniform meter rule that is not light. I can have a light meter rule that is not uniform. Do you get that? So that's the first thing that you need to take note of there. So now for this question, how did the question read it. So now from what you can see on the board, everybody, this meter will start from 0 and ends at 50. Is it uniform? Of course it's not. It's not uniform, because if it is uniform, it should start from 0 and end at 100. I don't know if you get that analogy. You should start from 0 and end on 100, but it's not like that. So now let's read the question. The question says that in the diagram above, a rod 50 centimeter long. I don't think I need to read that to you. A rod 50 centimeter long of uniform cross section is suspended horizontally of a fulcrum F by the action of the forces. What is the weight of the rod? So the question is asking us to calculate what? Weight of the rod. So now that will take me to my second note that I need to tell you. The weight of a rod, the weight of a rod will always act at the center of the rod. Will always act at the center of the rod. So that is where you need to take note of something else. Now the third thing you need to take note of, that if you are given mass, convert it to weight. If you are given mass, convert it to weight using weight equals mg. If you are given mass, convert it to weight using weight equals mg. So those are the things that you need to take note of. So now they are telling us that we should look for the what? We should look for the weight of this object. And since we are looking for weight will act at the center, and the center of 0 to 50 is what? 25 centimeter mark. So that means the weight is here, and it's the weight we are looking for. But they did not draw it inside the question. Now, from the formula I've given you, I said that sum of what? Anti-clockwise movement is equal to what? Sum of clockwise movement. Some people have run to go and eat. Continue. So I will take my movement to this side, and to this side. So which one? When you say anti-clockwise, that's one that is going against your clock. When you say clockwise, that's one that looks like your clock. So this weight too that I'm looking for, I'll take it to the fulcrum. So which one is anti-clockwise? This one. So that means I'm going to say that what? 200 times, what's the distance between this place and this place? That's 15 minus 5, and that's 10. Is equal to weight times difference, distance between 25 and 15, that's 10, you multiply by 10, plus 40, what's the distance between this place and fulcrum? Not here, this place and fulcrum, that's 45 minus 15, and that's 30. So you say 40 times 30. So this will give me what? 200 is equal to what? 10W is equal to what? Is it 200? 2000 is equal to 10W plus what? This one will be what? 1200. So I'll now say that 10W is equal to what? 2000 minus 1200, and that will give me what? 800. Then W will now be equal to what? 800 over 10, and that will give me what? 80 Newton. So the weight of this rod in the first place is 80 Newton. Take note of that. It's not more than that. It's not more. One more time is going. It's not more than that. Please, do you understand what I explained? That's how we used to solve anti-clockwise, clockwise, anti-clockwise, clockwise. A quick recap. Dari. Holy Spirit. Jesus. Hey. Oluwa. Just copy the question. We'll solve another one. And that will be the last question. So we'll solve one more question on that. We'll solve one more question. So, and that will be the last question for today. Oh yeah. We still want to do waves. Can I rub the board? I only want to solve one more question on that aspect and we'll end it. It's not hard. If you just put your mind to it, sum of anti-clockwise movement is equal to sum of clockwise movement. The anti-clockwise, you gather them together, you add them together, they will be on one side. The clockwise movement, you add them together and then you equate them together. And then from there, what's wrong with this quote? Let me give you pancake. Guy, why are you shouting? Are you okay? Are you? What's your stress? What's your stress? Why are you shouting? Are you a goat? Are you a goat? Stop shouting. See your head. You're shouting like e-goat. That you are. Rubbish. Shouting like you don't have manners. Sorry, Jerry. I want to go and discipline that goat. So let's quickly take the second question. Let me hear you shout like a goat there. But I will not slap you. I used to beat you. So let's take one more question, everybody. So I want to believe that by the time we take probably this question, it will be clearer. Okay. Let me rub the board now. You still want hey, it's good chop with no good today. Cannot keep quiet, Abby. Then this one is 100. Then on 10 centimeter, I'm having 20 gram. Then on 30 centimeter, I'm having 10 gram. On 30 centimeter, I'm having 10 gram. Then I'm having my fulcrum at 50. My fulcrum at 50. Then on 70, I'm having my M. So now the question is saying that with what I have here, I should calculate the value of M. I should calculate the value of M. Please, can you all see the good? Okay, that you draw by yourself. Yeah. All right. I just see that, so I'll put that. Yeah, I know they might not draw the diagram for you. I get that. Oh yeah, let's do this first. Let's do this. So now, if we calculate M, how do we do that? We'll start by saying that what? Sum of what? Sum of anti-clockwise movement is equal to what? Sum of clockwise movement. So I'll take this one to the fulcrum, take this one to the fulcrum, and take this one to the fulcrum. It's not more than that. So what are my anti-clockwise? 10 and 20. What is my clockwise? M. That's all. So I'll say that 10. Are you with me? So you can convert this one to, what's it called? To weight. But if you convert it to weight at the end of the day, you still have to convert it back to mass when you get what you get here. So many times because they are all masses, we don't used to convert it. Because it's like you're saying that 10 times 10 here, it will be equal to 10 times 10 here. So that means this 10 can cancel 10. Or let me say 5 times 10 and 2 times 10. So, it's still like saying 50 equals 20. I'm not saying it's equal, but I'm saying that since you can cancel 10 here, then you can also say 5 is equal to 2. Do you get? So, since it is divided by 1,000 I will, or by 100 I will be doing here, I will be doing here. So that divide can cancel out alone. So that's why we might not need to convert. So that will now be 10 times what? 10 times, what's the distance between this one and this one? 10 times 20 plus 10, Abi, no, 20 times, what's the distance between this one and this one? That's what? 40. The distance between 50 centimeter mark and 10 centimeter mark is 40. Then that will now be equal to what? That will be equal to what? What do we have here? The anti-clockwise, I mean the clockwise movement. M times what? M times 20. That's what we have in there. So what is 10 times 20? 200. What is 20 times 40? That is what? 800. Is equal to what? M times 20. That will give me what? 1000 is equal to 20M. Then M will now be equal to 1000 over 20. And what would that give me? That should give me 5. I'll be 50. Yes, that will give me 50 gram. So M that is here is 50 gram. So do we get that? That's the answer to that. M is 50. So let's take a question on the one that they will have to ask you to interpret yourself. I will ask you to interpret yourself. Let me check Lamlat. Still have Lamlat. Do I have Lamlat physics? Do I have Lamlat physics? Oh, I have. I will beat this goat. I have Lamlat physics. Lamlat physics. So yeah, open. Lamlat physics. So if you have Lamlat physics, you can just follow me. That's chapter 2. It will be on page 22. All right, so can I call a question in Lamlat physics now? Question 24. Question 24. Question 24. So let me call question 24 now. Some people, their intestine is already entangling together. If I see one food in your mouth there, okay. It's like people don't know the reason of that 2 o'clock that we are saying. You say that you pass 200. You did not get. Why did I not say you should fast till 1? If you go and break your fast before 2 o'clock, don't let me talk. So let's call the question. A uniform meter rod, let me just write it. It's pivoted at one end. A weight of 7 Newton is placed at the center of the rod. The vertical force which should be applied at the other end to maintain the rod in equilibrium. In the horizontal position. That's the question. The question states that a uniform meter rod of mass 1.5 kg, a uniform meter rod of mass 1.5 kg is pivoted at one end. A weight of 7 Newton, a weight of 7 Newton is placed at the center of the rod. A uniform meter rod of mass 1.5 kg is pivoted at one end. A weight of 7 Newton is placed at the center of the rod. The vertical force which should be applied at the other end. The vertical force which should be applied at the other end to maintain the rod in equilibrium in the horizontal position is. So now, looking at this question, is there anybody that can interpret it by drawing? Let me give you 1 minute. Quickly draw it so that when I'm drawing it, you will know if you know it. Try it. Try it. Try it to know if you know it. Yeah, try. Anybody? A uniform meter rod of mass 1.5 kg. So the first thing is that since I know that it is a uniform meter rod, that means it will go from 0 to 100. Do you get that? It's pivoted at one end. That's the next thing to note. A weight of 7 Newton is placed at the center of the rod. A weight of 7 Newton is placed at the center of the rod. Full stop. The vertical force which should be applied at the other end to maintain the rod in horizontal position is. Try and draw it. Let's see who can come up with something. Done. All right, Christabel, well done. I know that you are the shadow of our time. You are the one even teaching me those days. I don't even know anything. Yeah. All right. I would have said you should send it to me, but I don't know. All right, so let's draw. They said a uniform meter rule of what? Mass 1.5 kg. And where will this mass act? You turn it to weight. Weight will be what? Mg. And that will be equal to what? 1.5 times what? Times 10. That will be equal to what? 15 Newton. Abi. So if it's going from 0 to 100, this mass of 1.5 kg will first act at center. That is what? 15 Newton. It's pivoted at one end. Can you hear that? They said it is pivoted at one end. So let's pivot it at this end. Please, I hope you are with me. So a uniform meter rod, I've drawn a uniform meter rod of mass 1.5 kg. I've indicated the mass by turning it to weight at the center. Is pivoted at one end, either of the two, but I'm pivoting my own at 0. A weight of what? 7 newtons is placed at the center. This is 50 centimeter mark, which is the center. Then after the fact that this one has weight, they still have placed another weight on it, which is what? 7 newton. Do you get that? It's placed at the center of the rod. The vertical force which should be what? Applied at the other end to maintain it. Normally, if this thing is on like a knife edge, so far I'm dragging it like this, it wants to come down. So now I need a vertical force here that will help me hold it for it not to like come down and maintain it in equilibrium. Is that vertical force that they ask us to calculate. That's all. It's not even hard. I know that my formula is what? Sum of anti-clockwise movement is equal to what? Sum of what? Clockwise movement. What's the, so this one will go to this place. This one will come down here. So which one is my anti-clockwise? This one. And that's what? The force times what's the distance? 100 is equal to what's the force here? 22. You add the two together. 22 times 50. Then that means F will now be equal to 22 times 50 over 100. Whatever your answer is the correct answer. So that's the way they ask you question. It can be more complex than this, but you just have to read it and solve it. The other part that they used to ask you question is that what's it called? Types of equilibrium, neutral equilibrium, clinical equilibrium. Those are the questions they still used to ask you again. Neutral, unstable, and stable. For your stable equilibrium is an equilibrium. An object said to be in stable equilibrium if when given a simple tilt, it returns back to its original position. An object is said to be in unstable equilibrium if when given a simple tilt, it does not return back to its original position. Why an object is said to be in a neutral equilibrium if when given a simple tilt, it moves to another position, but it is still maintaining its shape. So this is a stable equilibrium. If I tilt this thing, it will come down again. Now, look at unstable equilibrium now. Unstable equilibrium. This one is unstable. Because once I tilt this thing, it's using the pointed edge to stand. Once I tilt it, it will it will just roll away. But this one, when I tilt it, it will return back to this position. It's like when I tilt your head will return back to your neck. But unstable is when I tilt your head and it does not return back to your neck again and it falls off. Why neutral equilibrium is not like something like this. When I roll this tire, it will go to another position, but it will still retain its shape. That's why it is neutral. So it will go and form the same shape in another position. That's why it is called neutral. And then they can ask you the examples of stable equilibrium, unstable equilibrium, and neutral equilibrium. So basically, this is all on equilibrium of forces. Practice more questions. Practice more what did I draw the vertical line down? I don't know what you're saying. So this is all on equilibrium of forces. You can just check it out. I know some of you are already very, very hungry. Hunger is your master. He's already calling you to come. So, but we want to do waves now. We'll start waves and we'll finish waves. So when we start waves and we'll finish waves, you can now go and eat. That should be around 5 p.m. sharp. We should be done with waves. So before that time, you cannot die. Will you die? You cannot die. So nobody should eat until that time. If you eat, if you taste water safe, if you taste water, it is well. Some people are already cursing me like that. Can come out and say it too. So please, that's basically all on what's it called? Your equilibrium of forces. So I want to stop here so that those that are fasting can go and break their fast. And once it is 3 o'clock, we'll be back but we'll be back for chemistry. I want to look at one or two things, especially probably your thermochemistry. I want to quickly touch it. That aspect of thermochemistry that used to give you people issues. Let's see if we can solve it. We shall come back by 3. I think that's enough. 1 hour break. People have tried, safe. I've tried. So by 3 we'll come back. We have like 3 to maybe like 4:30. So then we'll rest again by 5:30. We shall be having it. Just ensure that today you're online. You're online. I want to believe you have gained from the class. My back. I've been standing for 2 hours. Please hope you gained from the class. And even if you did not understand everything, you understand something. That's what matters. So let me release you to go and eat. Let me. No. Okay, the person that is talking about vertical line. This vertical line cannot be drawn down. They said, where is it? The vertical force which should be what? Applied at the other end. Now, let me ask you a question, that person. This thing now, and it's heavy, and it's already dragging this thing. You to think about it now. The person that asked that question, look at this. This is like the knife edge. Then I'm placing this thing here. You can see that it's already even falling off. So now if I want to apply a force that will not allow this thing to fall, will the force be acting like this or like this? It has to be like this. I don't know if you can see what I'm saying. This is like knife edge and this thing is falling down because this thing has weight. If I'm still applying another vertical force, it will be dragging it down, not up. That's what I'm saying. So it has to be up so that it will maintain equilibrium. So let's stop there. Hope you shall learn something at least. So I'll reach out to you when the next class is about to start. You should send my food though. Send my food. God bless you. So see you in the once I drop this video, you will not be able to see it again. Once I cut it like this, you cannot see it. Cannot see it. Okay. See you in the next session. Bye bye.